Freightliner's container depot at Birmingham. A train of containers arrives at the depot. It's the morning train from Holyhead, with containers from Ireland, for delivery to various destinations in the Midlands. One of the hundreds of trains run every day for Freightliner, carrying container traffic all over the country. To keep track of all their containers, Freightliners use a computer system. It's run by a specialised bureau, Freight Computer Services. To store the data, they use a more flexible structure than files. It's a database. To see why they need a database, we're going to look at the kind of job their computer system must do. Freightliner deal only with containers. Basically, a container's just a box. You lift it from one set of wheels to another. And that makes it versatile. At the end of a long train journey, it can be delivered locally by road. Freightliner carry private containers as well as their own. And there are many different types, varying in size and even in shape. You can put a covered load on a flat container and handle it in the same way as the boxes. That's because containers come in standard lengths. They're usually multiples of 10 feet. This container's number is 54N85. Freightliner AIM-class containers are 30 foot long. That's 3 standard lengths. Other standard sizes are 20 foot and 40 foot. So keeping track of all these different types of container is a major task. Manager of Freightliner's Birmingham depot, Harold Cross.
Freightliner is the world's largest inland carrier of containers, and we carry something like 750,000 containers per annum. We also own 6,000 containers, and it's quite a job in controlling and monitoring those sort of movements. So along with Freight Computer Services, we have introduced a system to monitor the movement of these containers. This has given us an up-to-date whereabouts of containers in the system, has helped us on the control and distribution of our empty containers to meet demands, and of course we are able to withdraw information up to 3 months old.
Oh, yes.
Every Freightliner depot has an office which deals with all the container movements in the area. And in each office, there's a computer terminal.
Freightliner's Birmingham traffic office. Hold on a moment, I'll do an inquiry for you.
If someone wants to know what's happening to his container, it's easy to find out where it is. It's just an inquiry at the terminal. This is a history of container 66K03. It's a list of all the recent computer messages dealing with this container.
Hello? The container is on hand at Birmingham, awaiting delivery. Thank you. Bye-bye.
We can see how the list is built up by taking a typical container journey. This container might start at a customer's factory near Birmingham and need transport to Glasgow. So the first thing that happens is a booking. The customer books 40 foot of space on a particular train, and that's entered into the computer. BOK means booking, the rest is detail. The same format applies to other entries at the computer. When the container arrives at the Freightliner depot, The computer entry is ING, in-gate. Next, the container's put on the train. That's called MOD, module loading. And when the train leaves, the exact departure time is noted. That's the DEP transaction. All the information so far has been entered into the computer at the departure depot. But it's also available at the destination, and it's needed for when the train arrives. The arrival transaction is just a report that the train has finished its journey. Once again, the exact time is entered. And finally, when the container leaves the depot, the last transaction is OTG, outgate. So whenever something happens to a container, there's always some paperwork. If a container leaves the depot, there's a form to be stamped. It confirms the container's on its way. And then the information from the form can be entered at the computer terminal. OTG means the outgate transaction, then the number of the trailer, and then the container number, 10F16. The transaction's been accepted, but it's just one of many thousands. So how does the computer organise its data? One way is to use a file of container information. Each record deals with one container. The key field is container number, and since fast response is needed, this would have to be a random file. But there's a problem. How much space is needed for each record? Transactions need to be stored for the container. As more transactions are added, the space in each record would run out. A problem like this can be solved with a linked list. In the Freightliner system, the container record itself doesn't hold all the past transactions. They're stored separately and linked together by pointers. Each new transaction is added to the end of the list, and the container records themselves can still be accessed directly. But some inquiries don't start with a container number, like this inquiry.
Freightliners Birmingham Traffic Office.
This inquiry is to find an empty container to transport a customer's load.
Just a moment, I'll see if we have any available.
You could find an empty container by going out to the depot and looking for one, but it's much easier to use the computer. These are the Freightliner N-class containers, empty at Birmingham and available for use. 30N99 would do the job.
Hello, yes, we have one available. Where would you like the container to go to? And the delivery address? Yes, we'll be able to do that for you. We'll load the container tomorrow and it'll be on the afternoon's train. Thank you. Goodbye.
And now a booking can be made. The train's number is important now. That's how the booking will be referenced. And the next line gives details of the booking. The numbers mean things like estimated weight, or whether the contents are hazardous. And that's more information in the computer system. And all this has to be structured somehow. Each container record has a field to show if that container's empty. But finding a suitable empty container isn't just a matter of searching the list. This container's empty, but it might be at Glasgow. And this one might be at Southampton. We want an empty container at Birmingham. So information about depots must be taken into account. Each depot has a 2-digit code. 75 means Holyhead, 77 is Birmingham. And the record for each depot and type of container has a pointer to containers of that type based at that depot. There's a pointer from this container record to the record for another N-class container, also based at Birmingham. And another pointer. This chain of pointers links all the N-class containers based at Birmingham. This container's empty, so its number can be printed at the terminal. We've only shown one chain of pointers, but there's a separate chain for each type of container and depot in the list. Information about trains is also stored in the system. Trains are identified by their train number. 77 is the depot where it starts, Birmingham. 75 is Holyhead, the destination. 293 is the day number. And each train will need a pointer to the containers loaded on that train. That's another pointer chain linking container records together. And you can see the system's starting to get complicated. From Freight Computer Services, Bill Stent.
When we started to develop the system, it soon became clear that we would need a database management system. This was because some of the data needed to be accessed in a number of different ways, and using a conventional file system would have required a lot more file space. We chose a tried and tested database management system instead of developing our own. This looks after the data on containers, on depots, regarding services, and maintains the relationships between those items. This provides the differing access methods we require.
And this is what the system looks like. The data is stored in nearly 40 different types of record. For example, this part of the system stores timetable records. And this box represents the depot records. And this box represents container records. There are about 100,000 container records alone. The arrows represent links between the different types of record. This arrow means that each depot record is linked to several trailer records. Each depot record starts a chain of pointers, joining all the trailer records associated with that depot. And all these links between individual records are kept up to date by the large piece of software called a database management system. Let's see how it works.
Have your CMI, please?
This container's just arriving at the depot in Birmingham. It's booked on this afternoon's train back to Holyhead. At the bottom right is the container number, 10F17.
Thank you, Fred.
And that's entered into the computer. ING for Ingate, 10F17 the container number, and the number at the end is the train number.
Every in-gate transaction uses this part of the database. Some of the records are checked for validation. For example, the timetable record is checked to make sure there's a train to the destination specified. But the container record isn't just checked, it has to be amended. If container 32N89 has arrived, its loaded weight is recorded and it's now on depot, awaiting a train. And the ING transaction must be added to the container's history. Once it's at the depot, the next stage in a container's journey is loading on a train.
Ground to L2. All this 32N99s for 6 road, okay.
Six Road is a track in the depot where the Holyhead train is waiting. The train's 1,000 feet long, and the giant cranes run up and down the track, collecting containers to fill it. Although each container's booked on the train, its position isn't fixed by the computer. That's decided by the ground staff at the depot. That's because containers come in different lengths. This is an N-class container, 30 foot long. But it'll be loaded onto a 60-foot wagon. If it shares with a 20-foot container, there'll be 10 foot wasted. So the crane driver positions this container at one end of an empty wagon. There'll be room for another 30-foot container to make up the length.
Hello, traffic.
Now the container's loaded in position 45. And that has to be notified to the office.
Okay then.
This board contains a diagram of the yard, and different sized cards represent the containers.
25 position. Okay, yeah. Yeah.
The small cards are for 20-foot containers, 3 per wagon.
Okay, so. Yeah.
And now that the train layout is shown on the board, that information must be entered into the computer. MOD module loading. This container's in position 42. And the one we saw, 32N99, is in position 45. The MOD transaction uses this part of the database. When the booking was made, one of these reservation records was created. And now that the container's on the train, a container consist record is created. Each of these records stores just one item of data, the container's physical location on the train. Our container's in position 45. When the train's fully loaded, it has to wait for the locomotive to arrive. Coupling and safety checks are another vital part of the operation. This could take another 20 minutes. But once it's done, the train is ready for departure. It just has to wait for the signal. And then the DEP transaction is entered at the computer, using this part of the database.
We found the database management system we chose to be very successful. It copes with all of the inquiries we handle. It's efficient in access time and storage space. And in the past 12 months of operation, We've experienced very few software problems.
So there are many different aspects to the Freightliner computer system. They're all geared to the efficient dispatch of containers. And it's been vital for this organisation to use a database management system.